How does digital audio production operate? As the term digital audio production implies, it involves storing audio information in a digital format. It's worth noting the remarkable journey that has made it possible for creators to produce music without the need for a fully equipped professional studio. Advances in computer technology and digitalization have opened the doors for anyone to create music at a professional level. In the modern era, all it takes to begin producing and mixing music is a computer and a set of speakers or headphones. But what does it mean to work in the analog or digital domain? To understand the distinction between analog and digital domains, we need to travel back to the 19th century. Even then, people aspired to record and play back music. In 1807, Thomas Young developed the kymograph, a device capable of recording audio signals, captured through the vibrations of a tuning fork, onto a soot-covered rotating cylinder. Unfortunately, while it could record sound, it had no means of playback. This changed in 1877 when Thomas Edison introduced the phonograph, a device that engraved sound vibrations onto a tinfoil cylinder and could also play them back. The same membrane that transferred the vibrations to the engraving needle was used to read the engravings, causing the needle to vibrate and reproduce the sound waves. The next major advancement came in 1935 with the invention of the magnetophone by the company AEG, marking the debut of the first type of tape recorder. By 1940, it became possible to create multi-track recordings using tape coated with magnetizable iron particles. During playback, the magnetic signals were converted back into alternating current, which represented the audio signal and its waveform, essentially sound waves. Until the early 1990s, 24-track tape recorders were the industry standard for recording, editing, and playback of separate audio signals. For productions requiring more than 24 tracks, engineers relied on mixing desks, developed in the mid-20th century and continuously improved since. These desks allowed individual signals to be summed and recorded together, making it possible to layer additional tracks and produce recordings with higher channel counts. However, analog tape recording had a significant limitation. Edits were irreversible. Cutting and splicing the tape was a permanent change. While tape recorders evolved, progress in the digital domain was also accelerating. Milestones included the Nyquist-Shannon theorem in the 1920s, Alec Harley-Reeves pulse code modulation in the 1930s, and the development of microprocessors in the 1970s. By the 1980s, digital tape recorders emerged, enabling digital signals to be recorded on a tape. The 1990s marked a major turning point with the introduction of personal computers into recording studios. These computers, equipped with software featuring graphical user interfaces, enabled digital audio signals to be recorded onto hard drives. Known as digital audio workstations, DAWs, these tools revolutionized music production. Over time, DAWs have become increasingly advanced, incorporating a wide range of functionalities and establishing themselves as indispensable tools in modern audio production.